What we're going to be doing today is a transect down the shore, and for that you're going to need a tape to lay down the shore so that you know where you are, and a quadrat which you're going to use to measure the density of the different animals and plants on the shore. The other things you need to do is check the tide times, and you can do that online. Make sure that you arrive on the shore at low water. Always work in pairs, just in case there are any accidents. Keep an eye on the tide as it comes in to make sure you don't get cut off, and also make sure that you are wearing appropriate clothing, waterproofs and Wellingtons. We're here at the bottom of the shore, and we can just see a little bit of the big brown flat seaweed just about exposed at low water. On very large tides, this would be sticking out of the water. This is the bottom of the shore, and this kelp will extend out underwater for many hundreds of meters. We're just above the kelp zone now, and this is a seaweed which you will always find at the bottom of the shore. It's called serrated rack. It's a brown seaweed, and if you look carefully at the edge of the leaves, you can see that they have little tooth marks like a saw, and that is why it's called serrated rack. On some parts of the shore which are exposed a little bit more to wave action than others, you'll find that the shore is more dominated by animals rather than plants. And we have 3 species of animals that you need to look out for in these areas. We have the limpets, which are a mollusk, a snail-like animal which grazes on the rock surface. We have large areas of barnacles, which are related to the crabs, and they live inside a little shell and filter their food out of the water. And we have the dog whelks, which are a snail, a carnivorous snail that eats the barnacles. We've now moved up the shore to about mid-shore level, where we can still see that there are lots of barnacles, limpets and dog whelks, but the large brown seaweed which dominates in this area of the shore has changed from the serrated rack that we saw lower down to bladderwrack, which is another brown seaweed, but this one, instead of having serrated edges to its leaves, has air pockets in its leaves which help it to float when the tide comes in. When you're doing the transect, you'll be using a quadrat. What you do with the quadrat is you randomly place it on the shore next to the transect line, and then you record what is underneath each intersection of the quadrat. It may be a seaweed, it may be an animal. But where it's a seaweed, check underneath the seaweed to see if there's an animal on the rock as well. We're now nearly at the top of the shore. This is the second top zone that we'll be looking at, and this is dominated by another brown seaweed, although it's actually bright yellow in colour, and this is called spiral wrack. If you hold it up, you will find that the leaves are sort of twisted round themselves, and you can also tell that it's spiral wrack by the reproductive vesicles that it has at the end of its leaves. What we can also see here is another important animal, another snail, the common winkle, which is otherwise known as the edible winkle, which grazes on these seaweeds. We're now right at the very top of the shore in the final zone, where we find yet another brown seaweed. This is called channel wrack, and if you look very carefully at it, you can see that the leaves are curled in on themselves, creating a little channel up the middle of the leaf. This is the seaweed which is able to withstand the greatest exposure. It can be dried out on a sunny day, and when the tide comes back in, it gets rehydrated and survives very well at this level on the shore. So now that you've come to the end of the transect, the next challenge is to analyse your data and interpret your findings when you get back to the classroom. From this you'll be able to see the zonation of the different animals and plants up the shore. Also, one of the other reasons that we do shore surveys is to look for particular animals which have arrived as a result of climate change. There are some species which like the cold waters around Scotland, and as our seas are warming, they are finding it harder and harder to survive, and they are being replaced by warm water species from further south.